Assalamualaikum and good day. Welcome to the second part of the microprocessor course, microprocessor 1 course. In this part, we are going to discuss about uh, 8086 microprocessor, which you know that this architecture of microprocessor is still being used until today's microprocessor. The only thing is the recent microprocessor they have additional techniques, but the architecture actually remain the same as 8086, which we are going to discuss in the second part of the course. Okay, before we can go to discuss about 8086 architecture, let us continue with a historical background. Okay. What uh, what the event that caused the important event that caused development of microprocessor until today. Okay, so in this part we are going to discuss about event which lead to the development of the microprocessor until today. Uh, we are going to discuss from the beginning. Okay, you know that 8086, Pentium Pro, Pentium 3, Pentium 4, and the Core 2 processor, which being introduced nowadays, actually go back to the basic architecture of 8086. Okay, uh, for this part, this lecture actually is you don't need to understand it. It's not essential to be understand for the microprocessor architecture, but it's going to be interesting reading, which historical perspective for the fast-paced evolution of the microprocessor. Okay, in the beginning, the microprocessor, before the microprocessor being introduced to the world, it is start with the mechanical age, okay, where the idea of computing system, which are not new, uh, the calculating with a machine actually dates from 500 before the century, okay, where Babylonians invented the abacus. Abacus, I think until now, even the kindergarten school also they are using abacus in order to understand mathematics. You can use to calculate. Okay, it is a first mechanical calculator, which a string of bits perform the calculation. Okay, it it was being used by the priests to keep track of the storehouse of the grain. And some of it, as I mentioned, is still being used. Normally, is in the school for understanding calculation. It is examples. Okay. I think this one is the most familiar that I think we can see until today. Okay, next in 1942. Okay. Previously, it's actually before the century. This is after the century. After 100, 1642, Mathematician Blaise Pascal invented a calculator construct of the gear and wheels. Okay, you have a gear where each of the gear it has 10 teeth. If it move complete one revolution, complete one cycle, then it will rotate the second gear one place. Actually, this is the same principle that we use in automobile odometer. Okay, when if you check at your meter in car, the odometer is the one that calculate the mileage of the car from the beginning. Okay, the total number. Okay, and this is considered as a basic of all mechanical calculators. If I'm not mistaken, most of you maybe have heard about Pascal programming. It actually, uh, the name is being given in honor of the Blaise Pascal. Okay, this is an example where you can, I mean, the mechanical part when it rotates, it has a lot of gears from for example, the first digit until 10 digit, for example, and the first digit complete one revolution, it will rotate one step for the second digit. These are all the mechanical calculator. And then there are also electrical age. This is during 1800, where advance of the electrical motor being introduced. Okay, you know that electrical motor is being introduced by Michael Faraday. Also, a multitude of electrically motor-driven adding machine based on the Pascal mechanical calculator. This is a common office equipment which been used until 1970s. And then Boma Corporation, Boma Brick was introduced handheld electronic calculators, which appear in the early 1970s. Okay, this is the electrical calculator in the early stage. Okay, Monroe also considered a pioneer of electronic calculator, which use the desktop model. Okay, this is the specification, for example, for function size of the cash register. And then in 1889, Herman Hollerich developed a punch card for storing data. Before this, the microprocessor, the way to store data is by using a punch card. Means that you put a hole in the card, and that hole is represent a data. And each time you want to use a microprocessor, you need to insert the card. Okay, where actually apparently borrowed by Jacket idea. Also developed a mechanical machine that counted, stored, and collected information stored on the punctured card. It is driven by one of the new electric motors. Okay, calculating by machine intrigued U.S. government. So is that it for more grant for the research. And then Hollerith commission to use system to store and tabulated 1890 census information. It is one of the application where in 1918 Hollerith formed a tabulating machine company which developed line of machine using punch card for tabulation. Okay, and then they will start to form international business machine corporation. Okay, it is well known until today, where we refer it more commonly as a IBM incorporation. Okay, punch card used in the early computer often called Hollerith cards, okay, in the name of the Herman Hollerith, which is a 12-bit code used on a punch card is called the Hollerith code. Okay, this is the machine which use punch card. Okay, it's considered it's quite big. This is the card. The card is the one that store the memory, used as a memory. And then mechanical electric machine dominated information processing until 1941. The combination of mechanical and electric construction of the first electronic calculating machine, where German inventor Konrad Zuse invented the first modern electromechanical computer. It is a combination of mechanical and electric. Okay, his Z3 calculating computer probably invented for the aircraft and missile design. Okay, this is introduced during the World War II. Z3, a relay logic machine clock at a speed of 5.33 Hz, which is slower, okay, to the latest now microprocessor up to gigahertz. Yeah, this is the electromechanical machine. There has been argue if like those being given adequate funding likely would have developed a much more powerful computer system. In 1936, Zeus constructed a mechanical version of his system, and in 1939 constructed the first electromechanical computer system called as a Zeus Z2. Okay, and Zeus also today is receiving a belated honor for a pioneering work in the area of digital electronics. Normally like that when somebody else not, I mean, they have done great thing after they are not in the world, they are start to appreciate them. People are start to appreciate them. Okay, first electronic computer placed in operation to break secret German military. Most of the processor actually being motivated by military application. Okay, because during that time, even now also, uh, most most of the government they give a lot of grant for the purpose of military application. They were recently discovered through the declassification of military document of 1943. Uh, if you look back, after the World War II, when the Japanese surrender, one of the agreement during the process of surrender of Japanese in World War II, the requirement for the surrender is to limit the development in military. Means that you cannot fund a lot for military purposes. Okay, system invented by Alan Turing, which use a vacuum tube. Okay, this is the start of transistor. Actually, Alan Turing also the one that uh, involved directly with the intelligence system. Okay, Turing called it as machine colossus, probably because of its size. You know, when you use a vacuum tubes, become larger. Okay, where although the design allowed to break generated by the machine, it would not solve other problems. So it is a narrow application, only the purpose of break secret German military codes. And also Colossus during that time is not programmable. It is a fixed program computer system. Okay, for today often called a special purpose computer. You know, even now also we have a fixed application. For example, there are a lot of small devices, embedded system. They are only used for a special purposes. For examples, you are we are also use microprocessor in the printer, for example. So the microprocessor in the printer being used is a fixed programmable, fixed program computer system. You cannot program it to be other than what the printer in utilize. Okay, where uh, the first general purpose programmable electronic computer system developed is actually at 1946 at the University of Pennsylvania. Okay, this is ENIAC, electronic numerical integrator and calculator. It considered a huge machine where it contained about 17,000 tubes, where it required 500 miles of wire, 500 almost 1,000 kilometers, and the weight is over than 30 tons, where it can do 100,000 operations per second. This is being done today by only less than 1 kilo of machine nowadays. Okay, programmed by rewriting each circuit. Okay, same as now we have a RAM. You can rewrite. The process took many workers several days in order to rewrite back. Okay, workers need to change the connection actually between the tubes, and also require frequent maintenance. Okay, this is in the beginning of the microprocessor system, which you can program, you can reprogram, you can have a memory. Okay, and then we have John Badin, which worked at the Bell Labs, the one that developed the transistor. Okay, and then followed by Jack Kilby at the Texas Instrument. And then we have IC need to develop the digital integrated circuit in 1960. Okay, we start with the IC where you can have a digital connection, the resistor to transistor logic. And then the first microprocessor developed at the Intel Corporation is actually at 1971. Okay, it is 4004 microprocessor. It is a 4-bit microprocessor. It is the name of the pattern. Okay, that is the part in the hardware part in the development of the microprocessor, the history, the event that leads to the development of the microprocessor. Okay, now in the programming advancement, once the programmable machine develop, program and programming language then start begin to appear. As early practice of rewriting circuit through too cumbersome, it's too difficult, it's a lot of work to be done. Okay, computer language begin to appear in order to control the computer. Okay, and rather than you change the hardware, it is even better if you can change the structure, the status of the microprocessor only by computer language. Okay, where the first machine language was constructed of 1 and 0 using binary code. Okay, you can, the machine language, okay, the one that you've been taught is an assembly language. Assembly language need to be converted to machine language. That's why you need a compiler. Every time when you code in assembly language, you need to convert it to machine language. And assembly language also considered as low level language, same as machine language. Okay, store in the computer memory system as a group of instruction where we call it as a program. It is considered more efficient than rewriting a machine to program it, and it's still considered time consuming to develop a program due to the sheer number of the program code that required. And then we have a mathematician, John von Neumann. Okay, this is the first modern person to develop a system where it accepts instruction and store them in memory. Okay, you have a memory when you only write it once and you can store it. Before that, every time you want to use, you need to write it. Where the computer called as a von Neumann, Neumann machine, which is in honor of his name. Okay. A one system such UNIVAC became available in early 1950s. Assembly language was used to simplify entering binary code. Rather than you use a binary, mean a machine code, then you have a assembly language. Where assembler allows programmer to use a mnemonic, for example, add, addition, and so on. As you know, the difference between low level and high level, like C, Pascal, Java, that is considered as a high level. The purpose in this course, we are teaching you about using the assembly, because the assembly you can access direct to the architecture of the microcontroller, all the registers. Compared to high level language, okay, C, C++, Java, or others, we consider as a high level language, where it is a general language where it cannot access uh, the microprocessor architecture. Okay, and it is general, means that you can use to any microprocessor. Okay, you use the high level, while assembly language only for a particular processor. You have assembly language for microprocessor Intel. Even 8086 is not same as 8085. It's not the same as 8081. It has their own assembly language. Okay, and then they start a Fortran or Pascal, or that all considered as a high level language. Okay, additional language has appeared as I mentioned it here. But escape basic use in many computer systems, okay, which is among the most common, but nowadays I use C, Java, or others. Okay, this is all about the high level language that we use. C++ is the one that commonly being used. In the beginning, high level language basic is the one that popular. Okay, that's why I mentioned that C++ replacing some of the low-level machine control software or driver were normally reserved for the assembly language, where, as I mentioned, assembly language still plays an important role. Okay, this is in the purpose when you are going to use high processing uh, volume of instruction. Normally, programmer prefer to use assembly language. Since assembly language you can access directly to the internal architecture of particular processor. The assembly also interspersed with C or C++ to perform machine control function efficiently. And some of the system you can use both of it. Okay? Use assembly in certain part and C++ in certain part. Some newer parallel instruction found where it can be in the Pentium or N40 programmable in assembly language. Okay, the world first microprocessor actually is Intel 4004. It's been introduced by Intel. Okay, it is a 4-bit. If we say about processor, when we say 4-bit processor, 8-bit processor, 16-bit processor, 32-bit, these numbers actually represent the address line. The data line. Okay, basically there will be three type of lines in the microprocessor. You can have a address line, data line, and control line. Okay. And when you mention about the name of the processor, 4-bit, 6-bit, 4-bit, 8-bit processor, 16-bit processor, 32-bit processor, it actually refers to the number of data line. Okay, for example, in this 4004, actually it refers to the 4-bit processor, which only have 4-bit data line. Okay. 4-bit microprocessor means this number actually refer to the data line. Okay, address this number of the address 4696, 4-bit wide memory location. So 4-bit wide means that the data line bit is a binary digit with value 1 and 0. A 4-bit wide memory location, often called as nibble. Nibble is referred to 4-bit. If 8-bit, we call it as byte. Okay, in this first generation of processor, it only have 45 instructions. And it is used MOSFET technology, state-of-the-art channel. Execute instruction 50 kilo instruction per second. 50 kilo instruction per second. Where it's slow compared to 100,000 instructions per second, which use 30 ton. Okay, the one that we have looked before this, SSNA computer, 1946. You can execute 100,000 instructions per second, but you require 30 ton of machine compared to less than 1 kilo, which you can execute 50 kilo instructions per second. Okay, the difference was that the 40 weighted less than an ounce. Okay, if the IC itself, but in order to make a system, you require additional, for example, power supply, crystal, memory, and so on. But the IC 4004 is less than an ounce. Okay, 4-bit microprocessor debuted in the early system and a small control system. Okay, being used. For example, shuffleboard game produced by Bailey. Okay, use 4004 Intel processor. Our main problem in the early microprocessor were the speed, the word width, and the memory size. It was so limited. Okay, evolution of the 4-bit microprocessor ended when Intel released the 4040, which is an updated of 4004. Okay, the advancement is in the higher speed, lack improvement in the word width and memory size. Only the speed is being improved, but the word width still 4 bit. Texas Instrument and others also produce a 4-bit microprocessor at the same time. Also, still survives in low-end application. For example, if you want to use a microwave oven and a small control system. Calculator still based on 4-bit BCD binary to coded decimal code. Okay, with the processor, a commercial viable product, then Intel released 8008, which is the extended 8-bit of the 4004. 8-bit refer to the data bus 8-bit processor. Okay, and address also been expanded to 16K bytes. Okay, a byte generally and 8-bit wide. Okay, 4-bit is nibble, 8-bit is byte. And a K, okay, a K refer to kilobyte, for example. Okay, the total number is 1024. Okay, where memory size often specified in kilobyte, kbytes. Okay, in 8008, additional 3 instruction is been added. So the total number is 48. Okay, provide opportunity for application in more and advanced system. Okay, for example, engineer demand to use the 8008. Okay, somewhat small memory size still considered as a slow speed instruction set limited usefulness. Then Intel introduced 8080 microprocessor in 1973, which considered as a first modern 80-bit processor. Then Motorola also introduced MC68000 microprocessor 6 months later. Maybe start to develop advancement microprocessor. 8080 and to a lesser degree MC18000 is usher in the age of the microprocessor. Other companies introduced their own version of 8-bit. There are also other companies, okay, for example, Fairchild, Morse Technology, Motorola, National Semiconductor, also Zilog, okay, considered quite a well-known microprocessor. Okay, only Intel and Motorola continue to create new improved microprocessor. IBM also produced Motorola style of microprocessor. Motorola sold its microprocessor division to now which is called a Freescale Semiconductor. Okay, Zilog, as I mentioned just now, also consider a well-known manufacturers microprocessor, and it focused on microcontroller and embedded controller instead of the general purpose processor. So what is the microprocessor and what is microcontroller? 8051, the one that you use in the previous lab, is the microcontroller. It means that it all built in a system in a single chip. It has memory, it has I/O port, it has timer, all built in. Microprocessor is only microprocessor. In order to develop a system, you require a memory, an I/O port, and so on. So what more special about the 8080? Yeah, this is the feature. 64 kilobyte versus 16 in the 8008, and then executed additional instruction which is 10 times faster. Okay. Addition which only take 20 microsecond on 8008 base system require only 2 microsecond in 8088 base system. And it started to use TTL compatible with 8008 is not directly compatible. Interfacing is become easier and less expensive. And then 8085 microprocessor. Actually, this is the one until now. Also, the technology is being used. I think past 2 years ago, we are still using 8085 in our lab. Okay, in 1977, Intel Corporation introduced the update version of 8080, which is called the 8085. Same also 8-bit general purpose microprocessor by Intel. This is a microprocessor which considered slightly more advanced than 8080, which executed software at even higher rate. Okay, it can uh, execute 700,000 plus instruction per second compared to 500,000 per second in 8080, where the main advantage is its internal clock generator and a system controller and higher clock frequency. Okay, you can use the higher clock frequency, means that the instruction can be executed more faster. Higher level of component integrated reduce the 8085 cost and increase its usefulness. Okay, that's why I mentioned even until past 3 years, we also in lab use the 8085. So Intel claimed that it sold over than 100 million of 8085. It considered as the most successful 8-bit general purpose microprocessor, and also manufactured by many other companies. Give the right to other company use the same architecture to manufacture. So it means that there are over than 200 million in existence. Okay, application that contain in 8085 will likely continue to be popular. But until today, also some of small application, it is reasonable to use the 8085. Zilog Corporation sold 500 million of their 8-bit Z80 microprocessor. The Z80 is quite known during my study in undergraduate. I'm studying 8-bit Z80 microprocessor by Zilog. Okay, the Z80 machine compatible with 8085 is about the same. Over 700 million microprocessor execute 8085 and Z80 compatible code. Okay, now a modern processor which being used until today. Okay, it is introduced at 1978 by Intel. It is a 8086. A year or so later, it released 8088, okay, which both device is 16-bit microprocessor. 16-bit means the width of the data line is 16, which execute instruction in as little as 400 nanoseconds. Means that it can execute 2.5 million instructions per second, which considered as a major improvement over execution speed of the 8085. Okay, we have the microprocessor kit, development kit in the lab, 8086. Okay, 8086 and 8088 addressable to 1 megabyte of memory, 16 times more memory than 8085. 1 megabyte memory contains 1024 kbyte size memory location. This is the total number of locations. Okay, higher speed and larger memory size allow 8086 and 8085 to replace smaller mini computer in many applications. General purpose mini computer means. Another feature was a 4 and 6 byte instruction cache or queue. Okay, this is the one that being introduced in 886, the different with previous version, which still being used until today. Okay, which is called the pipeline. Okay, queue that prefetch instruction before it can execute it. The queue speed operation of many sequence of instruction basis of for the much larger instruction cache found in nowadays, but it still use the same architecture of 8086. The only thing is much larger instruction cache. Okay, increase memory size and additional instruction in 8086 lead to the many sophisticated application being used. Improvement to the instruction set include the multiply and divide division instruction, which is didn't have in the previous microprocessor. Okay, multiply and divide. In the previous uh, microprocessor, you need to add in order to do the multiplication and minus, subtract in order to do the divide instruction. Okay, number of instruction also increase. Okay, 45 for 4004, 246 for 8085. Here in 8086 is become to 20,000 variation, 20,000. Okay, we are going to look later on in our next discussion, our next lecture. Okay, this microprocessor we call it as CIS. Okay, CIS means complex instruction set computers. If you are going to take the microprocessor 2, especially for electronic student, you are going to study RISC. Okay, uh, the other microprocessor called the other kind of microprocessor. For 8086, it is a CIS complex instruction set computing. And RISC is reduced instruction set computing. RISC we refer to the ARM processor. Okay, additional instruction is tasked for development efficient and sophisticated application. Okay, this is true for the high processing instruction if you are going to use it. 16-bit microprocessor also provide more internal register storage stage. Additional register allow software to be written more efficiently. Okay, if you have a lot of register, it is more efficient to write the program. Evolve to meet need for larger memory space. Okay, popularity of Intel ensured in 1991 when IBM chose 8088 to be used as a personal computer. Okay, you know we call it what? I also forget. Before the Pentium, okay, you have 286, 386, 486, and 5 actually refer to the Pentium. So at the end of it, we call it 86 because it's based on the architecture of 8086. When it being used in the personal computer, then you start to use a spreadsheet, a word processor, spelling checker, and computer-based treasurers were memory intensive, where it required more than 64K bytes of memory found in the 8-bit microprocessor to be executed efficiently. So that's why a 1686 or 8088 provide more space for this application. And nowadays we have 64-bit of processor, the latest processor. Okay, I think this is the end of the lecture, first lecture. We are going to continue in next in detail about 8086. Okay, see you next time.